Hi, this is Alex from devstories.eu. Async IO, episode 17 of 20. You drop a standard background thread into your async web server to handle a slow task, and suddenly your application starts deadlocking or throwing cryptic state errors. Mixing standard threads with an async event loop is a recipe for disaster unless you use the designated thread-safe bridges. Today, we are covering threading in an async world. The primary rule of async IO is that the event loop runs in a single thread. Because of this, almost all async objects are not thread-safe. A common mistake is spawning a standard background thread, doing some work, and then trying to resolve an async future or schedule a callback directly from that thread. If you touch an async object from a thread other than the one running the event loop, you will corrupt the loop state. To send a message from a background thread into your async loop, you must use callSoonThreadSafe. This is a method on the loop itself. You give it the callback function you want to run and the arguments. Instead of executing it immediately, your background thread places that callback into a secure internal queue. The main event loop checks this queue and executes your callback safely in the main thread during its normal cycle. This is the only safe way for an external thread to poke the event loop. Now, consider the reverse situation. You are running your async event loop and you need to execute a piece of synchronous blocking code. A classic scenario is querying a slow synchronous PostgreSQL driver like psychopg2. If you execute a 5-second database query directly inside your async request handler, your entire web server halts. The event loop cannot process any other network traffic or timers until that database query returns. Here is the key insight. To prevent the loop from freezing, you push that blocking work out to a separate thread using run-in-executor. This is another method on the event loop. You give it a thread pool executor and your synchronous PostgreSQL function. The loop hands the function off to a background thread in the pool and immediately returns an awaitable object. You await that object. While your database query runs in the background thread, your async event loop is totally free to pause that specific task and go handle hundreds of other web requests. Once the PostgreSQL driver finally returns the data, the thread pool safely passes the result back to your event loop. Your awaitable resolves and your original async function resumes execution right where it left off, now holding the database results. You have two one-way bridges. Use callSoonThreadSafe to push events from a worker thread into your async loop. Use run-in-executor to push blocking synchronous work out of your async loop into a worker thread. Never let a synchronous call hijack your event loop, and never let a background thread touch your async objects directly. That is all for this one. Thanks for listening, and keep building.